Hi, my name is Frederick Lintz. I am the CEO of Exostiv Labs. Today I'd like to review and demonstrate some of the core capabilities of our new appliance, Exostiv Blade. Exostiv Blade is based on a chassis with flexible hardware resources configurations. This platform can scale its resources according to the user's need, and this at various levels: bandwidth, number of physical ports, memory, local storage, and so on. Exostiv Blade uses 25 gigabit per second transceivers grouped by 4 to extract data from the units under test. A single physical connection between Exostiv Blade and the unit under test uses a single QSFP28 connector on the blade and provides up to 100 gigabit per second capture bandwidth. This is the first core capability that I will demonstrate today. This capability scales quickly. A single hardware unit in this 2U chassis already features 4 of such ports for a total aggregated bandwidth of 400 gigabit per second. Exostiv Blade is based on a client-server architecture. It can be controlled remotely, enabling multi-site and multi-users FPGA test infrastructures. This is the second core capability that I will demonstrate today. Here is the demonstration setup. We have connected one of the QSFP28 ports of Exostiv Blade to an external target board where we find 4 SFP28 connectors. The target board is the KCU116 evaluation kit from Xilinx with the Kintex UltraScale Plus device. The target host generates a stream of data onto the FPGA PCI Express interface. After buffering in a FIFO, this data is sent over to the board DDR4 memory. Then the data is read back, buffered in FIFOs again, and sent back to the host across PCI Express. We inserted an Exostiv Blade IP instance to capture data from the PCI Express and from the DDR4 interfaces in the FPGA. This data is sent at 100 gigabit per second to the Exostiv Blade thanks to the FPGA device GTY transceivers. Everything from the capture setup to the data visualization is done remotely across a VPN. Here is the Exostiv Blade client-side application. We first recall a session settings, which include the parameters of the Exostiv Blade IP and how it is connected to the blade. Now we need to connect to Exostiv Blade. Clicking on Scan Networks updates the status of the Exostiv Blades available for this session and this user. Here is our Exostiv Blade, and we connect to it from the distance across a VPN. From here, we can set up the parameters of the capture. The Exostiv Blade IP is connected to some of the nodes of the PCI Express interface located in the FPGA. We'll now capture 4 million samples of this set of nodes. You can see here the resources that this capture requires. Here we go. By default, the captured data is stored onto the Exostiv Blade drives and can be visualized from the distance without having to copy the database. We of course provide options to store or copy it onto other network drives in various formats. You can see that there is no or very little lag when visualizing the waves, even if it is done across a VPN. Let's sum up. During this session, we have demonstrated 2 of the core capabilities of Exostiv Blade. First, the ability to capture massive data from inside FPGAs and send it to an external memory at 100 gigabit per second using 4 transceivers. Exostiv Blade allows aggregating this type of resource to reach even more data from the same or multiple FPGAs. Second, the ability to fully control Exostiv Blade remotely from a client-side application. We did this across a standard VPN from my home office with the demonstration setup located in our company lab. This enables multi-site, multi-target, multi-user FPGA test infrastructures. Thank you for your attention. Bye-bye now.